Hey, I'm Marcus. I would like to run you today through a couple of demos we have been doing with the Engelbart call taker client that has been developed on Avaya Breeze Client SDK, and we're currently showcasing it in a couple of European locations. So this call taker client is coming from a specific security project where the customer wanted to exactly have that kind of client in that kind of format based on a touch PC, and Engelbart software was developing according to customer needs. So it has been expanded with other capabilities over the time, and we were including more and more features. The demonstrations I'm going to run you through are all more or less in the area and circumstances of emergency communication. And you know, in emergency communication you always have an originating side and a terminating side, and there's a path between those. So from the originating side to the terminating side, this is where communication happens. The client I'm going to introduce to you in a minute is well suited, of course, and best suited in the termination side of the emergency communication. This is the kind of touch PC client that in the command and control room users want to have to get access to the features and the capabilities. But it's also acting as an example of the art of the possible, what could also be done in a public safety answering point or command and control room, so rather in a private network control room. This kind of client approach has been done based on, as I mentioned already, the Breeze Client SDK. So the capabilities are, of course, telephony, communication, but much more beyond that. And if you believe that there is environments out there, public or private network environments, where this kind of client might be a little bit heavy, just think about bringing some of the capabilities and some of the functionalities onto a Vantage device. So this was the introduction. Let me right now get ready in order to start the different demonstration use cases for you. So this is the demo setup I would like to run you through. This is our touch PC client, which you can use for incoming and outgoing calls. It's acting in this environment here on a call center elite based ACD platform. And this is where calls are coming in, or where information about calls is coming in. And then we have on the other side the originating PC for emergency calls, where we have an Equinox client and where we also have a client that is used for IP Office. You will see that later with a more close-up picture. This is the IP Office client that I run on the same PC like the Equinox client, and we're using it for creating an e-call as well. Here we go, ready to rumble. Now, first situation that you would like to think of is the originating side of an emergency call. What is happening when someone in a private network in an enterprise environment is dialing 112 or 999 or any other emergency number? Of course, it has to go to the outside world without any blocking, so just out for public safety emergency services taking care of it. But if you think about what is the environment that a call has been originated from, this is an enterprise environment, and probably that's where organizations would want to understand, hey, someone has just raised an emergency call and I would like to act based on the emergency call if I only knew where it was. So let's do the first step in here. I am creating an emergency call, calling my emergency number. That emergency call is now going out, and this client in here, this is not our public safety answering point, but this is the client inside the enterprise environment where you don't see any call coming in here, but you see the emergency button is flashing, and this is the information we want to have here. Now, touching the emergency button brings you additional information to this. We know which has been the originating number, who has originated the call, where is the location of that call. Here it's the Engelbart offices in Ravensburg. It's the room number that the call has been originated from and the seat number. And we also know in this case here, well, there's a first responder assigned to that floor, and this is Dirk Engelbart himself. So from that kind of information we can get an understanding where this call is coming from. We extract that information from the IP desk phone that has been originating the call. And you can have multiple sources of information to understand where geographically in a building a call can be originated. Now that we understand where the call is coming from, we can also add a floor plan to this. Now this is the desk where the originating call has been coming from. Now you get that information, and this PC here, this could be a screen at the receptionist desks. So the receptionist of the building should be aware that maybe a few minutes later the paramedics, the emergency response team is coming, and they want to get access to the building and they want to get access to the floor. So with that information in your hand, you can start now preparing the situation. Well, you could think about if there is a big flat TFT screen in the back of the receptionist, why just not stop the corporate video that is running all the time and display the floor information about the emergency origination point? Or add some other information into that. You could even trigger a printer on the receptionist desk to print out that floor plan. And you could probably also send this kind of information or a reduced set of information to the guard sitting at the entry gate of the location of the campus with the multiple buildings. So the guard should be warned as well. Something has happened. It's an ambulance call that has been raised, and probably please expect to open the gate in the next couple of minutes for not letting the ambulance stand outside. So that kind of information is really, really useful. And if we now think about the use case that in many buildings, in public buildings or wherever, on places and streets, CCTV cameras are more and more common, we can think about, well, we know exactly where this call has been originated from. Why not find the closest possible CCTV surveillance camera and just add it to the picture? And here we are getting that information. You see, well, this is me sitting in my office here, and I have raised the emergency call. So this is the part of the story which is dealing with the in-house notification about an emergency call that went out to emergency services. First part of the story. And let's close the window here again. What I'm going to show you now is a different use case. Just consider we are now talking about a different scenario. That client now here is in a public safety answering points command and control room. You're receiving emergency calls on here. And the following scenario is talking about next generation 112 or next generation 999. And this is a new use case which will come to life when the overall transition from ISDN to SIP-based communication has been affecting emergency communication as well. So these kind of use cases become available when we have an end-to-end SIP connection, where inside the SIP invite message we can start collecting information and sending the information over to the public safety answering point, so that the person in the public safety answering point has a better understanding of the situational data and of the location where the call has been coming from. So just imagine, one of your customers is migrating from ISDN to SIP trunking. He has probably 10 locations in a specific country, and each location in the past has been attached to the PSDN with an ISDN access line. These ISDN access lines, primary rates, basic rate interfaces, are going to go away in the future, and they all are going to be consolidated in SIP trunks. Now, this SIP trunk is decoupled location-wise from the origination point. So let's have a look how, with that changed situation where location information is decoupled from network access points and hand over to the PSDN, we can still transport location-based information from within an enterprise network. I'm going to raise an emergency call with my IP Office system here. So IP Office is a communication system that can make use already of encoding location information into an emergency call as part of the SIP invite message. And we have built the address of that IP Office system into the SIP header. I'm now calling the emergency number, and as you see, the emergency call is getting in. I am looking at the situational data, taking the call, and this is where my emergency call now currently is coming from. This is the location. This is the civic address where the call has been originated from. And this civic address has been used in order to determine in a mapping application, in a geographic information system application, the origination place. So you see here, this is our campus, this is the building where the floor has been originated from. This is somewhat the representation of the service provider's data, of the billing address, but well, in a SIP environment, the billing address maybe is one address where you get your monthly payments from, but in practice, the building is not the only place, it's not the only location where calls can be originating from. It can be all the other buildings and sites as well in that enterprise environment. And we are going to embed explicit information into the SIP invite message, which can be read once we have an end-to-end SIP environment at the public safety answering point as well. So this was our next generation 112 use case, and I'm going to drop this call here now. The next thing that I would like to show to you is raising an e-call, so an automated call from a car in an accident situation. E-call is a European law that is requiring car manufacturers to build in so-called in-vehicle systems into their cars, new car models that they want to sell into the European Union after April 2018. And on the receiving end, the public safety answering points have been able to receive these kind of e-calls. So an e-call in principle is a voice call to 112, which contains for the first 6 to 10 seconds a modem signal, and inside that modem signal the location information and car related information is transported into the public safety answering point. Now let's have a look at how this is working. In the first step we are going to use the e-call development tool that our e-call specialist partner Ökon is using. I am creating an e-call here right now, hitting the call button. And once that's done, the development server is dialing the emergency number, and with the emergency number the whole process is starting. So it's collecting data from the in-vehicle system and it's transcoding this into a modem stream. And now you see on the incoming side we have our emergency call coming in, and with the emergency call we have the situational data of where the car currently is at the time when it was creating the emergency call. It gives us 3 locations, so the current location, the N-1 and the N-2 location, and with that we can see where the car has been going the few seconds before the accident was happening. This is really important for responders to know in case this is a 4-lane motorway with a separator in the middle. You need to understand from which direction you're going to bring the ambulance car and the intervention team. Beyond that we see the vehicle identification number, and that vehicle identification number can be decoded, and with that you will know exactly what car, brand, type and model this is, so that the responders that would probably have to put their big iron scissors to the car in order to free people from within the car would know exactly where to put these scissors with the rescue card that they can pull out of their books. Now you also see that this is a diesel car, and you see the direction of the car, and you could also add another time the CCTV camera that might be very close to where the car currently is and show that video in here. Now this was an e-call from a simulation environment. The next demo is going to be the real thing. This is a real in-vehicle system. This is a box that can be built into a car in order to become e-call compliant. You see it's built by a manufacturer driver's mate. And this in-vehicle system has got all the connectors to it, the audio connector and different sensors connections, in order to create the activity that we wanted it to do. Because while this now is not built into a car, I have a box with buttons that we can use in order to create the e-call. And now I'm going to create an e-call from an in-vehicle system, holding the button for a few seconds, which is triggering the sensors in order to create an e-call. It is going to call 112, well, not really in this case, but it's going to call the emergency number. And after a few seconds, the modem is going to send the information over. And here it is, our incoming e-call from an in-vehicle system. We have the location data. You see, this is exactly the location where I am currently. So that GPS signal has come through to the in-vehicle system in here. And we have again the vehicle identification number, the classification of the car, the passenger count in it, propulsion type, and so on and so on. So now you have seen the two different ways to demonstrate e-call. Okay, so with that, let's move to the last demonstration. The last demonstration is about mobile phone originated emergency calls and how to deal with them in specific situations, finding out where a call has been originated from and the conditions of the call. So I'm calling from my mobile phone, my public safety answering point. The call is originating here. See that? The call is ringing. So let me pick up the call. And with the call being picked up, well, we now have to understand where the call is coming from. As the caller can't tell me, I'm asking him if I can use the location services built into our platform, which we call Locate Me, or iLocate as we know it in the Avaya world. So hitting the Locate Me button is triggering, you see, an SMS service. That SMS service is sending the SMS, and here we go. The SMS has been arriving. I click onto the SMS. I find a web page being pushed to me. And it's asking me, do you want to share your current location? Yes, I definitely do want to do this. And once that's done, you see immediately the situation data is coming up. And it's showing me where I am, right? It's showing me on the map where I am, and it's showing me the calling party number, and it's showing me on the map in the public safety answering point where I am as well. So this is location. Now it's pretty precise down to the grade of the location from the smartphone. If we want to enhance the operational view into the situation, well, let me take a picture shortly. Taking a picture opens up the camera. I put the camera on here and create a picture. Yes, let me use this. And once that's done, the picture is going to be uploaded, which is taking a couple of seconds before we are going to see the situation button flashing again. Depending on the network situation that you are in, this can take a couple of seconds. And you see, it has been appearing here now in the situation data field. This is working as soon as you are on a phone call where you can have an internet connection in parallel. So a typical 3G environment should be fine. I've done this a couple of times, and you see the call is still up. So we can now return to the call and have that information and continue the conversation with the call taker. We have location information, we have the picture that has been sent, and everything around. So the last circumstance that might really be cumbersome is when someone is calling you that you definitely do not understand because of a language issue. And talking about artificial intelligence, I think this is going to be solved very soon as well in the next couple of years, when there are algorithms that can hear from the spoken word which language is it on. In first trials, that was already somewhat successful, probably not fully yet there, but I'd like to show you what we can do with these kind of things. So let's start the translation in here. And in order to really hear what I'm saying, I just now need to take the phone onto my ear, start the translation process. Here we go. And I have to talk in German, otherwise it doesn't understand me. So, jetzt schauen wir mal, was bei dieser Übersetzung so alles rauskommt. Und wenn das Ganze durchgelaufen ist, dann werden wir irgendwann auch eine Übersetzung dort finden. Das ist natürlich etwas Satz für Satz ein bisschen schwierig, aber im Großen und Ganzen werden wir nach einiger Zeit hier sehen, dass man durchaus daraus lesen kann, was hier gerade passiert und damit der situative Kontext deutlich besser erläutert werden kann. So you've seen that. What has happened in here, there was a transcript of the spoken word. The transcript was translated with a web-based translation service. Maybe not the best possible one, but just consider you're not looking into every single word. You want to understand the context in here. In that context, you can now imagine easily that you can start typing back to the caller in the language of the call taker, which is going to be back translated into the caller's language, and then with text-to-speech going to be heard on the receiving end. So yes, these were the demos. Call is staying up. Going to drop the call right now, and I hope you liked it.